Okay, welcome everyone to this Unreal Engine tutorial. Today we're going to be making a true first-person aim-down sight system. So, let's dive right in. So, how this is going to work is what we're going to do is effectively put the right hand in front of the camera and then move it down the offset value between the hand and the sight on the weapon. So the hand will be right in front of the camera, and we will get the offset, or distance, from the hand bone to the sight, and then apply that vector offset to the hand bone, so that the sight will be centered in front of the screen. However, we will be avoiding placing the hand directly in front of the camera, first by using a scene component to act as a placeholder position for the camera's location. Then, what we're going to do is take that scene component, which is in front of the camera, representing the hand bone in front of the camera, and apply the offset between the hand bone and the sight to it. Then, we will use IK nodes to move the hand to the location of the scene component. So I'm going to assume that you already have your own true first-person system set up. I'm not going to go through how I set up mine, because mine is pretty lackluster. It took me like half an hour to throw together, so there's not much to see. All I really have here is a camera component that is attached to the head bone of the mannequin mesh. I also have an aim offset on the mannequin mesh. I'll leave a link in the description if you need to figure out how to set one of those up. I also have a weapon mesh here, a weapon blueprint here, and it's just a skeletal mesh that I have set to a weapon mesh, and I'm not going to go over exactly how I set all this up because I assume you already have it done in your own project. And then just in my third person character in the event graph here, off of begin play, I just spawn the weapon and promote it to a variable. You will want to do this. If you don't have a reference to your weapon blueprint, you are going to want one, because we will need it for the ADS code, and then I just have it getting attached to a socket on my mannequin mesh. Now, something to notice here over my components list is that the camera is attached to the mesh component of my character. Now, the code will work if the camera is not attached to the mesh, or the mesh is attached to the camera, or whatever setup you have. This code will still work. So you do not need the camera to be attached to the mesh like I have here. I just have it set it up this way because that's how I chose to set up my first true first-person character, but really these two can be related or not related in any way, and everything I'm about to show you will still work in your project. Okay, so what you want to do now is, with your camera component selected, click Add Component, and we're going to add a scene component. Call it whatever you like. I'm going to call mine R and underscore IK component. And just make sure it's in the center of the camera here. And if it's not in the center of the camera, then over here on the right here, just reset the relative location and rotation to be 0. Okay, so what you want to do now is open up your weapon skeleton and just make sure you have a aim point socket, and make sure that socket has the same rotation as your IK component. You'll just have to do less math if they have the same rotation, so yeah, just make sure they have the same rotation and you will be golden. Okay, so let's head over to our event graph in the third person character blueprint. We're going to right click. I'm going to make we need an event for the for aiming down sights, so I'm just going to use the right mouse button down event, right mouse button, and let's create a new Boolean variable. We're going to call this B is aiming, and surprise, surprise, we're going to set it to true when we press the right mouse button, and false when we release the right mouse button. And then, off of the true node here, so after this node, we want to get our right hand IK component, so hold control, we're going to drag this out, and drag off of the right hand IK component and type set relative location. And we're going to drag this off to the side because our ADS code will go here, and then after this set relative location, we're going to drag off of our right hand IK component again and just set relative rotation. This little arrow next to the compile button, if you click on this, you go to save by compile. I turn mine onto always, so when I compile, it'll save automatically. So we just want to compile and save, and then we'll move on to the next step. Okay, so what we're going to do now is get a reference to our mannequin mesh here. Drag off that and type in get socket transform, leave it in RTS world, and the socket name will be hand R or whatever the right hand bone of your mesh happens to be. Drag it down a little bit, get a reference to your BP gun variable, drag off of it. You want to get the mesh, I assume it's skeletal mesh, but if it's static, get that mesh anyway. So, and then drag off that. You want to get the socket transform, leave it in RTS world. That socket name is going to be the aim point socket from earlier. So mine is just S underscore aim point. Leave it in RTS world. And what we want to do is from our get socket transform of the weapon skeletal mesh, type in make relative transform, and it will be relative to the hand R bone, or the right hand bone of your mesh. And then we want to drag off of this return value and break the transform. Okay, so what we want to do now is get a reference to our right hand IK component. We want to get the relative location, and then we want to drag off of that and type in vector minus vector. And this, we're going to keep that as the top pin here. And then for the second bottom pin, we want to right click, split struct pin, and then take the location from the break transform of the make relative transform. We want to break that vector, and what we're going to do is hook up the X, hook up the Z, and then the Y. I'm actually going to multiply this by a float value of -1, because in my project the Y value, if not multiplied by -1, it was essentially just on the wrong side of the screen. So multiplying it by -1 will put it back where it needs to be. And then just hook up that vector subtraction into the new location for your set relative location of the right hand IK component. And then for the set relative rotation, we'll just grab the rotation from our break transform over here and plug that right in there. Okay, so now we're going to go over here to where we have some space. Let's right click. Let's make a new timeline. I'm going to call mine aim timeline. Double click to open it up. Set the length to be 1 so we can easily scale it later. And I'll show you what that means in a little bit here. At a float track, I'll call it alpha, and you should call it alpha 2 because you'll need an alpha value for a lerp node. So let's add 2 keyframes. The first keyframe will be at time 0 with a value of 0, and the second keyframe will be at a time of 1 with a value of 1. And then just right click on your first keyframe, and under key interpolation, click on auto to give you this nice smooth curve here. And if it doesn't give you the curve, do the same thing for your keyframe, for your second keyframe. And then head into your event graph, and then off of the alpha, drag off of this pin, promote it to a variable, and we're going to call it R hand underscore aim alpha. Hence us naming that float track alpha, and hook that up to the update pin right here. Let's drag off our finished pin. Let's get a branch node, and our condition here will be our B is aiming variable. And if we are not aiming, then we want to set the relative transform of our right hand IK component to be 0, 0, 0, or its initial location. So off of our event begin play code here, let's get our right hand IK component, let's get the relative transform. So the transform of the right hand IK component right as this blueprint is initialized. Drag off of it, promote it to a variable. I'm going to call mine r hand r hand default t, and then surprise surprise, we're going to take our hand default t, this variable we just created, hold control and drag it into our event graph and hook it up into our new transform from our set relative transform up here. Okay, so let's just compile and save. You'll notice here that we actually haven't hooked anything up to any of these input pins here. So let's go back up to our right mouse button or aim event. Off of is aiming, when we set is aiming to true, we want to get our aim timeline component from the left hand components tab under the variables section. So we want to get our aim timeline, and we want to call the play event, not play from start, just play. And I'm going to hold control and drag the pin out of the output from the set is aiming value. Take that execute pin, plug it into the the second execute pin from our play timeline, and then hook up these pins together so they all connect nice and neat like that. And then we want to get our aim timeline again, and after we set is aiming to false, we want to reverse the aim timeline, so it'll go back and we won't be aiming anymore. And one final thing before we head into our anim graph is after we set our right hand default transform, I want to get another reference to the aim timeline, and we're going to set the play rate to be 4. So essentially what this is going to do is it's going to take the play rate of the aim timeline, which is 1, and it's going to, we'll set it to this new value, which we have to be 4. But because we set our aim timeline to have a length of 1 second, the timeline will now play at 4 times the speed, and so it will be, the length will actually be 0.25 seconds now. And that's why I had you set it to be 1 second, this length to be 1 second, so that we can easily dilate it using this set play rate node. Say if you had set this to like 2, then multiplying it by 4, it wouldn't be, you just have to do a little more math to figure out what that time would actually be, that play time. Okay, so now let's click on our mesh, double click the mannequin mesh, open up the Anim blueprint in the top right, head over to your event graph, right click and type in begin play, and we're going to call the event begin play event, and then off of that type in cast to third person character. The object wildcard will be try get pawn owner, which is the same as it is down here. And then as third person character, you want to drag off, promote to variable, call it character. I already have my character variable created from my aim offset that I set up, but we can just hook this up like so. Okay, so go to the end of your update animation code here, get a reference to the character variable you just created. Remember to control click it to get a reference to it, and you want to right click on it and select convert to validated get, and this is the exact same thing as getting the character reference and typing is valid and doing one of these. It just does it in one node instead of 2, and it'll just check to make sure that this is a valid pointer, or that there's a value set to this, right? So let's create 2 new variables. One will be called r hand ik alpha, and that's going to be a float value. And then the other one will be a transform called r hand IK, and then you're going to hold Alt and drag both of these variables out into the event graph to set them. And the rhandIK alpha we can set to the drag off from our character and type in get rhandIK get alpha rhand aim alpha, and set that to our rhandIK alpha. And then before we set our right hand IK here, we're going to create a function that will get this transform value for us. So create a new function called get right hand IK. We're going to need to set an input to be an input called character, and that will be of type third person character. So drag off from character, and we're going to get the right the IK component. So IK component, we want to get the world transform then, and get a return node, and hook up the world transform return value into the return node. It'll automatically add a return value for that transform, so we can compile and save. And just make sure you make the function pure up in the top right here, so that way we don't have to hook up any execute pins to it in our event graph. So head over to your event graph, grab your get right hand IK function, drag it into the event graph, hook up the return value into our right hand IK here, and the character input parameter will be the character that we the character reference from our validated get over here. Let's head over into your Anim graph. I'm going to disconnect my state machine here, and I'm going to type in, I'm going to drag off it and type in new saved cached pose, and I'm going to call that base locomotion, or loco for short. And then over here for your output pose, in front of your output pose, let's get cached, use a cached posed base loco, hook that up to whatever animation code you have here. If you have none, that's okay, you can hook it right up into your output pose, and then just right click in your graph here and type in FABRIK and hook that up to your base locomotion cached pose. Again, I already have this local to component node here created, so I'll just hook that up like so. And then your effector transform is going to be your right hand IK. I know, that is a mind blower. So right click on, or sorry, just normal click on your FABRIK node. The effector target is going to be none because we're not using a bone, we're using a world space transform. So your transform space is going to be in world space. And your rotation source will be copy target rotation, because we did set the rotation of our right hand IK component over in our code here. So we want to make sure we use that rotation with our FABRIK node here. The tip bone will be hand R, and then the root bone will be clavicle R. Now this clavicle R is the end bone for this FABRIK node. So essentially what this is going to do is it's going to take this tip bone, and it'll take all the bones from the tip bone to this root bone, and it'll include those in an inverse kinematics bone chain. So it'll move this tip bone to this this right hand IK location, and then it'll move all of those bones from the hand R up to the clavicle as well. So it's not just gonna like take the right hand and then stretch it all the way to where it has to be. It'll move these bones from the hand, from the tip bone to the root bone as well, so it looks natural and not like a glitch. And then finally, I'm just going to set the position here to be 0.001 just so it's a little more accurate. And from our alpha pin here in the fabric, we just want to get our right hand IK alpha variable and plug it in, and we are done. And you can see the guy over here in the right is aiming. Let's see if this works. Hit play, we can aim down sights, and you can see we are aiming. There's obviously a visual glitch here. Because I set my near clip plane to be very, very close to the camera. So the weapon, what's happening here is the weapon is actually clipping into the camera. So okay, so I fixed my near clip plane, restarted the editor, and I realized that I'm still getting that glitch. And it's because in my third person character, off of the finished pin for my aim timeline, this branch here should go to the set relative transform when is aiming is false, not when it's true. So if you caught that, good for you. If not, then you should fix that right now and you should be good. And you can see the aim down sight system works pretty well. So I'm just going to briefly explain how this works, and this will tie back to the theory I explained in the beginning, but essentially your right hand IK component, this is the hand bone in front of the camera, right? Because this is your offset between the hand bone and the sight. Your IK component, with its relative location, that is the hand bone in front of the camera because it is directly in front of the camera, right? So we're just applying that offset, the sight offset, to the right hand, which is in front of the camera, which is what this vector subtraction is for. We're applying that offset, and then then the IK component is, down here somewhere, and then you put the hand there, and the sight is centered to the camera. So this is your hand, hand, I'm saying that with air quotes, because it's not really your hand, but that's what it's representing. This is the offset. You're taking this offset, adding it to the relative location of the hand, and just setting it here, and then we're just IKing the right hand to this C component. And yeah, so if you watch the theory bit at the beginning, it's a little bit more of an in-depth explanation, but that's kind of how this code here ties to what I explained at the beginning of the video. If you have any questions about how this works, or if you want to see something else, let me know in the comments below, and I will do my best to make it happen. So until next time, have a good one, and I'll see you later.